Alright guys, welcome to this page of the notes. Now what we're going to do is we're going to begin to take a look at how do you go about giving me a translation vector if you're given the pre-image and the image. So let's go ahead and first start by talking about writing a vector in component form. So far, right, we know how to name a vector, and I've named one for you here. This is going to be vector JD, meaning the starting point is J, the ending point is D, and I use that little half arrow to show that it is a vector. And I've graphed that vector for you guys right here, that vector JD. Now, we can write a vector in component form, and hopefully you can see this here in the notes. It may be a little fuzzy, so let me just go over it again for you real quick. Those are not parentheses. What we use are sort of what I like to call little triangle brackets. Okay, they definitely have a point to them. They shouldn't look like parentheses. Make sure you give them a little angle there. That way you'll recognize it as a vector, right? If you ever see two numbers inside of those kind of angle brackets, it's going to represent the components of a vector. The x, the change in x always comes first. So the horizontal shift is always going to be the first number. Let me go ahead and put that here. The horizontal change will always be A. Remember, horizontal is in the x direction. The vertical change is always going to be the B. Vertical, of course, being up and down, a change in the y. So when it comes to this, a vector JD will have the components A, B, right? A is going to be the change horizontally, the change in the x. The B component is going to be the change vertically, the change in the y. So if you wanted to, you certainly could think of it like this. JD, if I give you the components of that vector, it'll be x, comma, y. And again, anytime you see those sort of angle brackets, all right, you need to, it's a vector, all right? You've never seen these angle brackets before unless you have studied vectors before, in which case, here they are again. But most of you probably have never worked with vectors before. This is the first time you're seeing angle brackets. It's the first time you're seeing them because we use them when it comes to vectors. So anytime you see those angle brackets, it's a vector. They're giving you the components. The first component will always be the horizontal shift. The second component will always be the vertical shift. All right, so let's go ahead and jump right into this and see what these look like with an example problem. They're really not too tricky. So if you feel comfortable, please work ahead. Come on back, check your answers with mine once you get done. Here's what I've done. I have given you the coordinates for a pre-image. Let's go ahead and plot those. I'll make this one A, B, C. So -2, 1, 1, 2, +1 right there. That's going to be A. B is going to be -3, -2. That's going to be B. C is at -1, -2, -1, -2. There's C. My pre-image is that triangle right there, given to me by those coordinates. Okay? Now, I have been given a vector. I know it's a vector because it's in those little angle brackets. I know that this guy right here is the change in the x. This guy right there is the change in the y. So what it's telling me is everybody needs to move in the x direction 4 units. That's +4. So everybody's shifting 4 units to the right. It then needs to move a +6 units in the y. That's going to be 6 units up. So we'll take every point and shift it 4 to the right and 6 up. Here we go. Let me do it in yellow. So 1, 2, 3, 4. 4, 5, 6. There is A prime. 4 to the right, 6 up, based on my components. Let's keep going. B. 4, 6 right there. That's going to be my B prime. And then C, do the exact same thing. Right there. C prime, draw your image. Sorry, got a little sloppy. I am freehanding this, but here's what you should see. If instead of in the previous problems, I put the vector, right? I graphed the vector on there for you. You found the components and performed the translation on the image. In this case, instead of giving you the vector, I've simply given you the components. But if you were to draw the vectors in there, they should all be identical. A to A prime, B to B prime, and C to C prime. All of those green arrows, same magnitude, same direction, right? The magnitude, 4 units right, 6 units up, all pointing in the same direction. Hey, let's keep going. I got another one for you right here. Okay, so what I've done is I've given you coordinates A, B, and C. Let's go ahead and graph our pre-image, and then we'll perform our translation based on the components that we've been given. A is at 3, 0. That puts A right here. There's A. B is at 2, -2. That's going to put B right there. C is at 4, -2. 4, -2, really tiny triangle right through there. Sorry, I drew straight through my A, but anyway, there is my triangle. Now let's go ahead and perform our translation based on my component vector. Again, remember the X is always given first. The Y is given second. What they're looking for you to do is translate every point 2 units in the negative direction, so 2 units left and 3 units up. We can do that. That's going to put A prime right there. B prime right there. C prime right there. Draw the triangle. And again, they didn't give you the vector. They just gave you the components. But if you were to put it in there, right, you should see all of those arrows are the same magnitude in the same direction, mapping our pre-image to our image based on the translation, the change in position, -2, 3, this vector. Now, again, take a look at the problems we just did. Hopefully what you notice, shape and size have been preserved. We didn't change the shape, we didn't change the size, we simply changed the position of the object, the image that we were, well, the pre-image, mapping it to the image. All right, and finally, here's what we're going to do. As promised, I will give you, right, I'm going to give you I'm going to ask you to give me the vector, the translation vector, if I've given you both the pre-image and the image. All right, so here we go. Take a look at this guy. 2 of these, because again, really pretty easy. A, B, and C, A prime, B prime, and C prime. So this is my pre-image, this is my image. I want to know what is the translation, what is the change in position. Well, I've actually already drawn the vector in there for you. Sometimes I'll give it to you, sometimes I won't. I definitely don't have to, but since I have, it's simply a counting game. Remember, the horizontal translation comes first, then the vertical translation comes second. So, horizontal first. We're going to shift everybody 1, 2, 3, 4, 5 units to the right. That's 5 units in the positive direction. So, the X component is going to be 5. Then, I started at B, so I'm going to need to go to B. That's going to be 1, 2, 3, 4 units down. Careful. That's a -4, right? That is a shift vertically down 4. So make sure you make that component negative, right? So there we go. Those are the components of my vector, which here I can just put in yellow for you right there. That's the vector that they gave you. And you have now written the components for that vector, 5, -4. Let's try another one. Again, should just simply be a counting game. Horizontal, the X comes first. Vertical, the Y comes second. So I'm starting, let's start at A. Let's go to A. And you know what? Yeah. I put the vector in there for you from A to A prime. But you know what? Let's go C to C prime. So starting at C, 1, 2, 3, 4. All right, so I'm shifting 5 units in the positive direction. That'll be 5. Then from C to C prime, now I need to go vertically. 1, 2, 3. That is a positive 3 because I'm shifting up. That translation is along that vector. Right there, the components are 5, positive 3. Let me write the 3 on there. Now, go ahead and double check it. See if the vector I gave you also has the components 5, 3. 5, 3. It will. It should, right? Every vector is going to be the same because it is a rigid motion, right? I'm moving every point the same distance in the same direction. Doesn't matter whether you do A prime, B prime, C prime. Doesn't matter. They've all been shifted the same magnitude in the same direction along this translation vector. The components are 5, 3. Guys, thanks so much for joining me on this set of videos. Hopefully at this point you feel much more comfortable with translations as a change in position, a rigid motion that preserves both shape and size. Thank you again for joining me. I'll see you guys next time.